Hello, this is a short demonstration video for my IoT project. So the main problem that I'm trying to solve in my IoT project centers around the problems with home working during COVID-19. Now, the real reason behind this is I want to spend less time actually sat at my desk doing work, and I think the best way to do that is just to work more efficiently. So is there a set of data streams that could be gathered which could allow me to achieve this? So I think if you have all of this data, some of the products that you could be able to get out at the end is things like designing an optimal schedule. So, you know at what hours of the day you work best, and then you should do your work then and nowhere else. So you're only working at maximum efficiency. So hopefully this should be allow me to spend significantly less time actually doing the work. So the data streams that I'm going to try and gather are going to be when the user is sat down at their desk, measure whether they are in a state of focus or not, and measure their digital work rate. And that's mainly going to be sort of tracking things like keyboard and mouse movement. Now to gather all of this data, I've got 5 data streams in total. Now, these are the keyboard data stream, the mouse and scroll data streams, which both come from the laptop. And then I'm using a camera here to detect when the user is sat down at their desk and also whether they're in a state of focus. And those are both done through image classification models running on a Raspberry Pi. So once all this data is gathered, it is then displayed in 2 ways. So one is on a web page through a dashboard and a series of graphs there using Chart.js, and the other is on a LED strip in my room to give a more real-time visual representation of the data. So this is the system diagram, which you can see on the screen now. It shows the 2 sources of the data, which are the user's laptop, where there's a keyboard listener running from the Pi input library, and then the second Raspberry Pi, which has 2 machine learning models running on it, one which detects whether the user is sat down and one which detects whether they're in a state of focus, and that gets its information from the Raspberry Pi. Now, both of these sensors then stream their processed data over Bluetooth to the Pi to the Pi 1, which is acting as a server. But the Bluetooth servers take this information in and store it in a local JSON file, where it is then extracted to provide the information for the LED strips, and also passed to the Node.js server, which is running, which is sending the information to the Firebase real-time database. So this is the Firebase real-time database. As you can see, the key values here are stored by the date, and then the children of each of those date key values are the same for each day and include cumulative values such as the data for over 10 minutes, data for the entire day, and then just the raw data. And you notice that it's stored with these push keys, which act as unique identifiers and are timestamps as well. This is the desktop of the Pi 2, which is connected to the PiCam. The first script that is run on this is the image classification one, execute model. This runs 2 image classification models, one which detects whether the user is sitting in their chair, and then another which detects whether or not they are focused at this stage in time. The second script being run here will connect this Raspberry Pi to the second Raspberry Pi via Bluetooth. So first it searches for all the nearby devices and then connects as the other one is automatically listening for it. This is the desktop of the Pi 1, which features the 2 Bluetooth server scripts, one which is connecting to the laptop here, and one which is connecting to the other Raspberry Pi, taking information from the camera here. So both of those take information in and store it in a local JSON file. That information is then taken from the local JSON file and sent to the Arduino via a serial connection. And then a Node.js server takes the information and pushes it to the Firebase real-time database at intervals of 1 minute. The LEDs in the room display 2 streams of data. One is the ratio of focused to unfocused work, shown as the green to red split in the current session of work, and the other, shown in blue, is the amount of time since the last break was taken. You can see it reset when the user gets up and comes back from a break. As mentioned, the data is also displayed on a web page, which has a dashboard for key features such as the number of focused hours a day and the number of breaks taken. It also represents information such as the maximum cursor distance moved, gives time series data charts for that day, compares the data over the last 5 days, and tries to find correlations over the last 5 days as well.